Hello guys, so we are back with our first video of this series. Uh, Today we'll solve CP31. Which problem? Third problem. I've already solved it, but to show you guys how I solved it, so we'll go into this question and let's just read the question. Uh, the question is of division 3, problem C. That means third question. So I don't know. Let's say I don't know how to pronounce it, so let's just say VN3. Okay. Aka and blah blah blah, two fellow computer programmers decide to give V a problem to test his skills. Okay. So we'll try to first let me open Skeletor. We'll try to uh, code the observation here as we go through the problem. Okay. So V is given three positive integers n, k, and x. So n, we have n, k, and x. Okay. So and he has to determine if he can choose k distinct integers between 1 to n such that their sum equals to x. So this is basically a very simple statement got you guys already understood, right? If someone didn't understood, let me just tell you. So what we'll be having, we'll having a number n. Suppose we have a number n equals to 5, so we'll be having 1 2 3 4 5 till 5. We'll having elements from 1 1 to n. Okay, so here are the elements 1 to n, and we have to find k distinct elements such that their sum will be equal to x. So suppose let's take an example. Okay, let's take a test case. So suppose here here okay, so here we have 5. Let me just check which one is the first, second, and third. N is the first, K is the second, and X is the third. Okay, so we have 1, 2, 3, 5. Okay, we have 1, 2, 3, 5, and we have to take K. K is 3. We have to take 3 distinct numbers so that the sum should be equal to 10. So what we can do? We can take 5 plus 3 plus 2. So this is equal to 10. So we'll just print yes. And if we can't do it, we'll just print no. Okay. So let's see why here is the output is printing no. So we have 5. Okay, 5. Let's only take this 5 elements, and 3. 3 is RK, and X is also K. So if we want to take 3, suppose we want to take 3 distinct numbers. We can't take less than 3. We have to take 3, or we also can't take more than 3. So if we take any 3, literally any 3 distinct number, it will be always be bigger than 3. The sum of k distinct numbers will be always bigger than 3 in the second test case. Okay, so yes, that's all. So if you guys thinking how this statement is possible, so let me just tell you. If you take 1 plus 2 plus 3, this is already this is already bigger than 3. We are taking this minimum k distant number in the series. That's only giving bigger than 3. So uh, to check above that, it's not like we don't have to check it. If the minimum 3 numbers are giving less bigger than if the minimum numbers are giving the sum bigger than 3, then we don't have to check the after numbers. Okay, so yeah. So we have to print yes or no if we can. So the first thought I got when solving this problem is, when I was seeing these test cases, we can't we can't tell if this if 1 2 what is the one if 1 to 2 lakh numbers can make uh, and we have to take these numbers these distinct numbers to make this sum. So we can't like try run all these because they are very large numbers. So we need to find some kind of some kind of common ground for all the test cases. Okay, so what I was thinking, what was my approach was, let's just take third this yeah is this the third test? Yeah, this is the third test case. So let's just take this. Okay, so 10 n equals to 10. Okay, k equals to 10 and x equals to 55. Okay, so suppose we if we if we what if we try to write n numbers from 1 2 3 and dot till 10. So what we have to do is, let's just take a range. Okay, if the smallest k distinct numbers are are lesser or equal to then the then the sum, then the given sum, and if the maximum sum of k distinct number are less or equal to the sum, then we can say the it will always will print yes. Why? Because let's see we'll take 5 3 10. Okay, okay, so suppose if we have 1 2 3 4 5 6 okay 5. Let me just delete all of these, they are making us confused a little bit. Okay, so if we have to take at least three distinct numbers so that the sum will be 10. So let's just take 1 2 3, so the sum will be 6. Okay, and we have to, this was our argument, should be greater than equal to or should be less than equal to than 3 plus 4 plus 5, that is 12. 12, are you sure? That is 5 6 7 8 9 10 11 12. Yeah, 12. Okay, I'm sorry. So yeah, 12. So this was our how can we move on, this was our argument. So if x is a number greater than equal to the least k distinct numbers and x is smaller or equal to, so why so you guys understood or not? I know you guys didn't understood, but this is what I can explain. Like this is my this is the best of my capabilities to explain this problem. So let's just code it. So first we have to declare k and x, and then we have to say all these numbers. Then what? So you guys are thinking how we'll take the sum of these starting k distinct numbers and ending k distinct number. So it's very easy. You know the formula from like 7 or 6. We have already learned that. So if we to note that we can, okay. So it's already, so we don't may exceed the 20 to the power. Okay, so we'll just have to use long log so that we don't get any altogether error. So long log is small k. Okay, so small k will be k. So this is the formula to have the sum of 1 to n numbers. Okay, So the formula is one second, sum of, okay. So now, so this small the formula is n into n plus 1 by 2. So this is the formula, okay. So we need to find the first we need to find the sum of smallest k distinct numbers. So we have to find from 1, so 1 is 1 being the smallest k distinct number from till k, okay. So if we have 3 here as k value, so we have to find the sum of 1 2 3. So what will be the formula? K plus 1 by 2. So this will be the formula. And for the largest value, for the largest k distinct sum value, we need to find the sum of last three numbers, okay. So what will be it, what will be that? 5 4 3. We have to find the 5 plus 4 plus 3, okay. So we'll do a simple k minus minus. So when the k becomes 0, it will stop the loop. So we can first, let's just make a big k, okay. So we'll just set it to 0 and we'll insert sum in this integer, okay, in this variable. So what we'll do big k plus equals to n, okay, and we'll do n minus minus, okay. So if n minus minus, okay. So what we are doing here is, like, suppose if we have big k equals to 0, starting we'll have big k equals to 0, then and k equals to 3, then then the loop will start, okay, okay. The loop will start, and then we what we'll do, yeah, now the k n values, and so in the second line, what we'll do, we are adding the value of n to the big k. So here we'll be what we are doing is, we are doing this, so we'll be so now the value of big k will be 5, okay, because it was 0 and the n value is 5. So to be more specific, it will be this, okay. Let me just write here, let me just, what the fuck, uh, and let me take this part somewhere else, yeah. So now k will be 2, okay. So big k value is 5, and then it the 4 will get plus, okay, because n is getting minus. So the value is 9, okay, and then the k will be 1, okay. So it will 3 will get plus because n is getting decrement by 1. So yeah, that's all. So after that, the k will become 0 and the loop will stop, okay. So what we'll do if else check, just if small, if x, wait, small, what was our argument? We write just like that. If small k is greater than equal to x, and x is less than equal to big K, then you can just print yes. Otherwise, you can just print no, right? So let's just try to pass this. What the fuck? Okay, so we have just wrote it wrong here. We have to do less than equal to, because if if the x come between the range of small x and big K, so we'll we'll print yes. Otherwise, we'll print no. So let's just try this. So it got passed, and this is how I solved this question. So thank you for watching. I know I've blundered my English a lot here, but you guys have to bear the pain of hearing me speaking English.